The biggest challenge in this room was the fact that it has a set of double doors on 2 walls and a single door on a 3rd wall. Now, I'm sure everyone knows it's not so easy to put screens and doors in the same location. The use of these doors meant that we had to come up with some novel solutions and really look at the way that we could optimise the room layout, not only to fit the screen in that was required, but also to make sure that the sound was as good as possible, and also we could get as many seats in as possible. The biggest choice that we had to make was to project across the room. The reason that we did that, of course, was that was the one wall remaining to us, which didn't have a door in it. It presented quite a number of challenges with the acoustics. You didn't want to get the seats right back against the rear wall because you get a problem called boundary gain. It tends to boost the bass to levels that you don't want to have. The other problem that we had to encounter was that if we moved the seats too far off the wall, the seats would sit in the second null point of the standing waves in the room, a nice technical term. We were able to design that out using positioning and using multiple subwoofers. And once we were sure that we were able to accommodate those two things, we could move forward with the design, both aesthetically and obviously to position the rest of the equipment. I think as anyone who's ever built a house or done any major renovations will tell you, the best laid plans don't always end up working in reality. We tend to find that most of the broad ideas work really well, but now and again you have to change a lot of the fine details. When it comes to construction, you'll find little things, a wall's not square, a door's a bit higher than you expected. Small details, but they all have a knock-on effect. And I think in this room we were fairly successful in sticking to the original design, but of course there had to be one or two, I don't say compromises, but one or two alterations, let's say, to the initial design to make sure that everything would fit in. But I think if you look at the renders though of the design beforehand, we got fairly close in this one to really matching that. There was a couple of unique features that the room really needed to have. The first thing was that Stuart wanted to have a TV and a projection system in here. Now, typical way that you would always do that is to use a drop-down screen, but a drop-down projector screen offers its own challenges. How do you integrate that in a nice way? Do you go in ceiling? Not always easy in a normal house. Do you have that on wall? It can be unattractive sometimes. So what we were able to do in this situation is to use a very clever fixed frame screen called the Cinema TV mask that allowed us to incorporate a fixed frame screen, a nice big fixed frame screen, and still allow a TV system to exist in the same space. I think that's been an excellent solution and certainly quite unique, I think. The other big design that we wanted to come up with, and perhaps it's one of those things that sometimes works a lot more easily on a computer than it does in reality, was a curved bulkhead design to incorporate the projector. Again, one of the challenges that you have is how to make the projector disappear into a space. There's a couple of ways that you can do it, with projector lifts or with mirror systems that drop down. But these drop down systems are quite expensive, and to be honest they can be quite unattractive as well. And we wanted to come up with something a bit different for this space. So the bulkhead was the way that it was done, and I know it was very challenging to construct, but the end result is very special. I'm very happy with the end result. There's a very unique projection screen in this room, a Cinema TV mask. Now, the Cinema TV mask actually incorporates 3 surfaces and a number of different masking panels. Now, the 3 surfaces that we have are an artwork, which you can see behind me, a white screen for projecting onto, And we actually have a cutout that enables the TV screen behind to obviously be seen through the screen. The way that that works is there are two rollers at the top and bottom, and those three panels can be moved up or down on those rollers as required to enable the appropriate part to be seen. Now, as well as those three sections, the screen actually has four-way masking as well. Now, what the four-way masking does is allow us to create any aspect ratio that we would want to have when projecting. It also allows us to really accurately frame the bezel of the TV with the black velvet masks so that we get a nice high contrast when the TV is on as well. Now, it's a very unique screen. It was the first cinema TV mask in the UK, in fact. So it was very exciting for us the day that that arrived. And Stuart was able to see it with the artwork in place and see how the different masks and everything all integrated into the system. One of the big trends in the last few years with home cinema projection has been the use of constant height screens, and we knew that we wanted to incorporate a constant height system into this project. What we had to do though was balance the very short projection throw that we had with really getting the optimal image on the screen itself. And the traditional use of anamorphic lenses is tricky in that situation. You need to use a very big lens, which is expensive and most certainly has optical distortions in it. The projector that was used in this system actually has what we call memory zoom, and the memories allow us to store the zoom, shift and focus. When we recall one of those memories, the image changes size on the screen and we can move it up and down as appropriate to compensate for any lens shift. Now, by teaming up this memory with the four-way masking, we're actually able to create any aspect ratio and within reason any size image on the screen, and that allows us to actually do a constant image height system with full four-way masking without the use of an anamorphic lens. The reason that we were so keen to get a constant image height system into this particular cinema, and in fact all of the cinemas that we're involved with, is when you look at the different content that you have, and I would encourage people to actually go and have a look at the Blu-rays that they've got, you find that probably 80% of them are in wide aspect ratios, 2.4, 2.35. Now, those aspect ratios are designed to be wider, to fill more of our horizontal field of vision than normal television at 1.78 to 1 aspect ratio. It's really an important part of the movie experience for me that when those films come on, they're shown wider and much bigger in fact than a normal 1.78 to 1 image. We've seen many times that cinematic effect is really one of the main things that people love about their home cinemas with the constant image height system, and that's why we were extremely pleased to be able to incorporate that into this design. Acoustics is always an interesting subject in a cinema design. You can go either one way, which is to have no acoustical treatment and hope for the best, or you can go completely in the opposite direction and have an extremely elaborate acoustical treatment plan. Now, my experience is somewhere in the middle of that. It always pays to have some acoustical treatment, but we're lucky that we live in normal rooms most of the time, which help us a lot to have spaciousness and reflections in a room. Now, we knew that in the case of this particular room, we would need to do some acoustical treatment, but we also knew that part of the aesthetic design meant that we couldn't go completely overboard on everything. Now, what we focused on with this particular room was to control reflection and reverberation. The room before had many hard surfaces and very little absorption in it. By absorption we mean surfaces where the sound strikes it, it's absorbed, soft surfaces like fabrics and carpets and so on. And by balancing out with some extra absorption through the use of fabric panels on the side walls and also on the ceiling, We were able to bring the reverberation time of the room down considerably, but at the same time we didn't over-deaden the room. That's perhaps the most common mistake that amateur acousticians make, is they fill the space up with absorption, which is equally undesirable. I was extremely pleased when we did the calibration and we saw how we had been able to control the reverberation times in the space. The next big challenge that we have with room acoustics is a subject of standing waves. I'm sure most people watching this will have heard of standing waves, but may not always know what they are. Basically, every sound that we hear is actually a pressure wave. Those pressure waves move through space and they have a certain wavelength dependent on their frequency. I'll spare people the physics at this minute in time, but basically the lower the frequency, the longer the wavelength. Now, wherever those wavelengths are some multiple of the room dimensions, you get this thing a standing wave. And we always have great delight in demonstrating standing waves to people. Basically, as you move across a space at a standing wave frequency, because the pressure doesn't vary in space, it stays constant in space, the actual sound level that you hear changes dramatically. Next to the walls, you can have an extremely loud bass that's almost shaking you off your feet, but you can stand in the middle of a room and hear almost no bass whatsoever. It's quite interesting, quite amusing to let people experience that for the first time. Now, people make a big deal about working with bass and how to get the best bass response, and standing waves are a challenge. The good news is, of course, that this was a rectangular room, and that meant it was very, very easy for us to predict where those standing waves would be. When we came to calibrate the room, our predictions were almost exactly correct of where the standing waves would be. And through a use of good subwoofer positioning, careful positioning of the seating positions, and through room DSP built into the audio processor, we were actually able to achieve a very consistent bass response across all of the seats in the space. So the standing wave problem that could have been really a big difficulty and a big impact on the performance of the room had been handled very nicely, and we were able to get really a powerful, deep bass, very tight, and that had good power at all of the seats in the room. Now, for AVForums members watching these videos, of course it's lovely to drool over the wonderful system that we've been able to put together here, but of course there is a practical application, we hope, for everyone watching and everyone who aspires to get the best possible home cinema experience that they can have. Now, there are a number of design tips that you can use to improve the performance of your home system. Now, this doesn't depend on your budget. The goal is to really optimise the performance of any system through the use of good design and some good knowledge, and hopefully these tips that we're about to present will give you that. The first and most important tip that I could give to anyone looking at a home cinema is to use multiple subwoofers. 3 or 4 years ago that was very uncommon, but I'm pleased to say that almost always now, certainly a better quality system has at least 2 subwoofers in it. Now, the use of multiple subwoofers is not just to give us higher sound output. In fact, depending on where you position them, it can be a little bit less efficient than using one subwoofer. But what it does is it allows you to really optimise the acoustical performance at all of the seating positions in the room. So even if that's something as simple as your normal living room, where you just have the TV, if you've got 2 subwoofers, you can have it so that you can have good bass at all of the chairs. Think how wonderful it would be if you and the wife could both enjoy good sound without any of the arguments about the sound being too loud. If you really get that set up correct and aligned properly with the main channels, there truly is no better way of improving your cinema experience. I've seen that now over many systems. and getting a well-integrated bass across the whole room is the single most important thing to do. So the use of at least 2 subwoofers, preferably 4 subwoofers, is absolutely critical there. The next design tip that I would suggest that people follow is to look at the positioning of their surround speakers. If you look in any AV receiver manual, or look on the Dolby website or the DTS website, they all use a standardised layout for 5.1 or for 7.1. Now, those layouts are actually based on angular positions. Now, if you follow those angular positions as closely as possible, what you find suddenly is that panning effects, as the sound moves from side to side in the room, become much more convincing. You get rid of those big holes that people talk about in the sound field. I think the most common mistake perhaps that people make is that they think the rear speakers need to be on the back wall. Now, we quite often see, especially in fact in living rooms, if you are firing across the room or you're going long ways in the room, it can be that those rear channels, angular-wise, would be on the same wall as the surround speakers. And I would encourage people, if they are able to experiment with that, and I think they will find that their surround experience becomes a bit more convincing. The panning effects in particular, they become more complete. There's not that gap in the soundstage. The next tip that I would suggest relates to your front speakers. The biggest thing that you can do to optimise the performance of the front channels is try and get all of them as closely as possible the same height with reference to the tweeter. And ideally that height would be the same as your seated listening height. Now, why is that important? In fact, all speakers are designed with a particular type of performance in mind. What you find is that most of them are optimised for what we would call on-axis performance. So on-axis being directly opposite the tweeter. Now what happens as you move further off-axis is that you start to roll off the treble, and perhaps you can get things like comb filtering and all these other acoustical things that people like to talk about. What you simply find is that if you can get the tweeter up there all in a line and all on axis, is that you get a much more even sound field, and you typically find a lot more detail comes out of the soundtracks as well. It's an excellent tip, not always easy, especially if it's a television that's being used, but it's certainly one that's worth trying to get them as close as possible. The next tip that we would talk about is really related to optimising your video performance. And there's no better thing that you can do to optimise your video than preventing light falling on the screen. We've already spoken in some of our other videos. It is nice to have a little bit of ambient light in the room, but always, always, always do your best to prevent that from falling directly onto the screen. It's actually possible to do a little experiment. If you have a little LED torch, just one single LED pointed at the screen can have a huge impact on contrast. And I've seen it many times where people have gone to fairly elaborate lengths to optimise their rooms with dark coloured walls and so on. And they forget about things like the light creeping in under the door or that gap in the curtains. And little simple details like that, if you can optimise them, you can really maximise the contrast performance that your equipment is capable of, and that, after all, has to be the goal that you're looking for in your home cinema, to get the best out of the equipment that you have. The final tip that we would really suggest to people is to try and optimise the height and the viewing angle of their video system, their display. Now, height-wise, it's very simple. The most comfortable position height-wise is for the centre of the screen to be directly opposite seated eye level. Now, that's not always easy with a projector screen, but with a TV, there's really a reason for that not to happen. The amount of times that we see very high mounted TVs, and it's just simply not comfortable to view over a prolonged period of time. You get neck strain and eye strain, and all of that can be avoided by just simply mounting the TV a bit lower. The only thing is you need to get over the mental stress of the TV not being in the middle of the wall, but trust me, it makes for a much more enjoyable experience. With regards to your viewing angles, an easy way of assessing your viewing angles is the size of your display, the height of your display should be 1/3 of the viewing distance. It's a nice, easy, ready reckoner that you can use, especially appropriate for projector screens, but gives a good tip for flat panel displays as well, if you're really looking for that big screen experience. And with 70 and 85 inch displays available in Currys now, then why not?